Alright, so number 8. We've got the two motorcycles, straight road. Folks, who's working on this one with me, just so I know who to direct. Okay, most of this table and a couple over there. Okay. Um, Straight road, heading north. Motorcycle starts constant speed. And the other one moves with a constant acceleration. And then I have a position time graph. So I'm going to start off with my Y. Should be here. And it's a written Y. Let's see. Since I have a position time graph, I want to show I understand that. So I know the slope of a position time graph is the velocity of the object. So if it has a constant slope, the object has a constant velocity. If the slope is changing, curved graph, the velocity is changing. And then I should probably show I understand the relationship. Acceleration. Anytime.
That's between you and I.
Mm-hmm. I see nothing.
Because I don't have enough for everybody.
I would never mention it. Thank you, sir. Acceleration is the rate the velocity is changing. Oops. Go ahead. I think that's everything. Let's see. What did they ask me? Pick which one is which. What is the position of two motorcycles when motorcycle passes? Oh, what must be true for things to pass each other? The what? The lines intersect. So what does that mean physically about the thing? No. They're at the same place. And that's one of those things we don't think about, right? We show that they're at the same place by the lines intersecting, and that's what it means to pass. Because you would think, oh, they have to have the same acceleration or the same speed, or one has to be going faster than the other. No, to pass, same place, same time, lines intersect. So I'm going to show that I understand that. Okay? So to pass must be at same place at same time, so the graph lines will intersect. So that looks spelled wrong. That probably means it's right. Cool. Are we good on the Y? Ready to do some Howie? Howie. It's been one of those days. It's going to continue. So part A, hopefully you can answer on your own. What is the position of the two motorcycles when they pass? So, I need to look at position, and let's think about what I know. I know at time 0, x is at 50, constant speed, 2 starts from this, constant time, 10. Oh, I know lots about time and velocities and accelerations, and I want to know about distance. So I'm going to use my snipping tool if it ever comes active. Come on, computer, you can do it. So I'm going to use this equation. Since I know things like they will be at same place, right? So that means that both of them will have the same D. Right? And it depends upon which one I want to look at, motorcycle 1 or motorcycle 2, but they're both going to end up at that same D, that same place, at that 10 seconds. So I know my time here. I know my delta T for me is 10 seconds. Which motorcycle do you guys want to look at? Number 1 or number 2? Number 2? Okay. So, number 2 starts from rest. So, I know if I start from rest, what's my initial velocity? 0. Okay. So, I'm going to look at motorcycle 2. So, I know my V initial is 0. Because it tells me starts at rest. I know my time, it's 10 seconds. And it starts at a position of 0. That's at x equals 0. So in my equation, that position where I start is this one here, the D naught. So my D naught is 0. And moves with a constant acceleration. Uh-oh. It doesn't tell me what the constant acceleration is. I can't right now because I don't know D, and I don't know A, so I have 2 unknowns and only 1 equation. So maybe I should put this part on hold. And let's go with motorcycle number 1. For motorcycle 1, it tells me at time 0, I'm at 50 meters. So it tells me that my D naught is 50 meters. Because it said at time 0. And moves at a constant speed of 6.5. So if I have a constant speed, what's my acceleration? 0. I'm going to call that acceleration 1. Because it's a different one. So my acceleration 1 is 0. And that means my V naught is, what did I say, 6.5? Yeah. Six and a half meters a second. So now, okay, so now, and I know my time still, right? My time is still 10. So I'm going to use this equation. I want to find D. I know D naught, for me it's 50, for motorcycle 1 it's 50 meters. I know V initial, 6.5. I know time, 10. I know the acceleration, 0. I know time is 10. Square it. So I can now solve and find out, hey, D is this. And let's see, meters per second, seconds, so that's going to be in meters. And that's part A. Or part B. Part B. We ready to look at the next part? Part C? No? Yes? No? Part C, what's the acceleration of motorcycle 2? Oh, now I know D. And I know all the other things in here, so now I can use that first equation again. So, this red thing wasn't lost. I just needed to bring this down to do part C this way. And I'm going to use my same equation. My time is still my 10 seconds. My V naught now is 0. My D naught is 0. I know my D from my previous part. And the only thing I have left to solve for is A. And then my units are working out also. I have meters and seconds and everything like that. So now I'll get my A, and that will be in meters per second per second. Okay. Motorcycle 2. Everything for part C I'm going to take from motorcycle 2. Yeah, I'm trying to use color to help with that. You think we're good on part C, or do you want a minute more to work on? What have you got? That's why I'm sitting here Thursday. Alright, on to part D. Part D says, what is the speed of motorcycle 2 when it passes motorcycle 1? Oh, I have so much information now. Look at your graph. Do you think they have the same speed? No, because look at this difference in slopes between the blue and the red line. Huge difference. So, but if I think about all the things I know the time, I know the initial velocity, I want to know the final velocity, I know the acceleration, but I also know the distance. So if I look at my equation, I have like choices. I could do it with acceleration and time, I could do it with acceleration and distance, but then I'd have to remember to square. I think I'll use a simpler one. I think I will go with this one, just because it makes my math simpler. So, I'm looking for V final. That's what I want to know. And I'm looking at motorcycle 2. So this is MC2. My V initial of MC2 was 0. My acceleration I just found. Oh, my time. That's my 10 seconds again. Oh, that makes sense. The acceleration is how much speed is being added every second, or how much velocity is being added every second. If I do that for 10 seconds, it's like multiplying the two together. Wow. Cool. Bored. All right, on to 12. A hot air balloon is ascending at a rate of 7.2 meters per second when the passenger drops the camera. What does ascending mean? Going up. And if the hot air balloon is going up at that, how fast is the person going up? Same speed. How fast is the camera going up? Same speed. So I might show that in my Y right away. That if the balloon is moving upwards, so is the camera. Oops, too many O's. So is the camera at the same speed. And then it's dropped. What does it mean when you drop something? Yeah, for dropping, you just let it go, right? You don't like push it in either direction. You don't give it anything different than it already has. But you're right, as soon as it's dropped, it's in free fall. That would be my next big point here. Once dropped, it is in free fall, thus accelerating downwards at 9.81 meters per second. Wow. I had enough coffee this morning. Into upwards. This one I might actually do a little drawing just to help myself think about it, right? Because I'm thinking here's the balloon, and it's moving up like this at some speed. The camera is going to start here, and it's moving up at some speed v. It's going to go up and then come back down, right? Because it's got to go up until it does what? Stops, and then it comes back down. But the whole time, the acceleration is downwards. Because it's slowing down, stops, and then speeds up. But under the same acceleration. So I'm told, let's see, let me put some numbers in here. I'm told I'm at 27 meters. So now I need to make a choice. Where do I want to call 0? So I want to call 0 where it's released or at the ground. Where is everyone okay with that? We'll call that 0 height. So this is 0 at 0 meters. We said that up was positive. That means the ground is negative 27 meters. Is everyone okay with that? Because remember, you could reverse that because you're in control. You control the universe. This I might include in my how, or I might include in my why. Either way. So they want to know the amount of time to reach the ground, and then eventually, what is its velocity just before it lands? Ooh, what direction is its velocity going to be in just before it lands? Negative. So the v here is going to be downwards. I might include that in my y to make sure I remember it, that I expect a negative answer for the second part. So I'm going to put that in. It will be moving downwards, negative, when landing. All right. I want to know how long it takes to get down there. I'm going to use this. Because they tell me some things here. They say, oh, I'm going to land on the ground. That's negative 27 meters. I'm going to start up in the air, which I call 0. I started by moving up, right? For me, I moved up at 7.2 meters per second. So this is how I started moving. Which for me is 7.2 meters per second. Do I know how long I moved for? No, that's what they want me to find, right? I know my acceleration. I'm in free fall. Negative 9.81 meters per second squared. Why is it negative? Because direction, because it's downwards. And what I'm looking for here is delta t. And I'll find it and it'll be in seconds. Because these are in meters, this was in meters per second, the starting velocity is meters per second, my acceleration is meters in seconds. So nicely I don't have to do any conversion. Good, you think? I'm just watching our time because so that's part A. For part B, they want to know how fast I'm moving. Is that right? Velocity just before it lands. Oh. I'm actually leaning towards using this one. Actually, I'm not. I lied. I'm going to use this one. I'm using this one because this is what I'm interested in finding, the final velocity. I know my initial velocity. This was what I started at. I think for me it was 7.2, positive 7.2 meters per second. I wrote 7.5. 7.2. This I know again, negative 9.81 meters per second squared. And that delta t comes from there. That was my answer to the first part, was delta t. So I use it again. I could use the v final equals v initial plus 2ad also. That one will work also. This one will give me a negative answer because notice it's velocity. The other one is speed, so it'll give me a positive answer, and I have to remember to write down negative. Either way works. All right, I will save these and publish them.